It's my pleasure to introduce today's presenter, Graeme Purvis. Graeme has been a technical instructor with IBM and Global Knowledge for over 20 years. He holds certificates across a broad range of technologies and platforms, including Windows Server NT, SQL Server, Salesforce, and SUSE Linux. Graeme, it's all yours. Let's begin.
Good morning, and welcome to this rather short, good evening, rather short presentation on SQL Server. I'm used to actually teaching the full 5-day courses, and this is a Reader's Digest condensed version of some of the highlights. So let's get moving. At any information, so your microphone will remain muted throughout the entirety of the process. So you're going to have to actually go and use the question and answer tool to actually submit questions. There's also a chat window available for you to actually throw up some comments as we actually go through. So as I was just introduced there, I have a number of different certifications on various different platforms, and specifically SQL Server. I've been dealing with SQL Server since SQL Server 6.5 all the way up through and including SQL Server 2017, and I also deal with the Azure variants of SQL Server. So this is intended to be a high-level overview of SQL Server and SQL Server availability options. So let's take a look. When we take a look at SQL Server, SQL Server started out life as a binary compatible implementation with Sybase. Up till SQL Server 6.5, you could actually directly exchange databases with Sybase. SQL Server 7, Microsoft actually went in and made some structural changes specifically to the way the data was actually stored. And that, in my mind anyway, is the beginning of SQL Server as we know it. As we go up through SQL Server, when we get to SQL Server 2005, Microsoft makes some major changes to the security architecture of SQL Server, introducing things like the schema class object and so forth. Various different new features and capabilities introduced along the way, including significant XML handling and so forth. When we get up to SQL Server 2014, SQL Server introduces a new model for transaction execution operations. So you have the traditional transactional model, which is referred to as row-based, and then you have what is referred to as in-memory or column-based transaction processing. And column-based or in-memory transaction processing gives you a potential factor of up to 30 times performance improvement, provided that the workload is appropriate for that form of transaction processing. So the current version of SQL Server that is available is SQL Server 2019. SQL Server 2019, incremental improvements over and new features on top of the prior version. When you actually take a look at the support lifecycle for each of the versions of SQL Server, you can actually see here that the currently mainstream supported versions of SQL Server are 2016 and above, although 2012 actually has extended support out to 2022. But if you are actually still working on SQL Server 2012, 2012 R2, you would probably want to be looking at migrating your workloads off to a newer version of SQL Server. Okay, so when you take a look at SQL Server, during the installation of SQL Server, you have a choice of a number of different SKUs of SQL Server. The SKUs of SQL Server are predominantly associated with the Standard and Enterprise Edition. The Enterprise Edition of SQL Server gives you 100% of the available features. If you go down to the Standard Edition, you save a little bit of money on your installation. However, there are a number of features turned off, such as the ability to actually do failover within a mirror set and things like that. There is a developer edition, which is feature identical to the enterprise edition and is licensed such that it cannot be used in a production environment. There's also a free version of SQL Server, the Express edition. The Express edition does tend to actually show up in a lot of environments because it's not only free, but it's also freely redistributable, and therefore a number of applications and services actually deploy that. We also have the Azure SQL database. There are a couple of different variants of SQL Server that you can actually run up in Azure. It is a separate and distinct version of SQL Server with a subset of the features that you actually have available to you in the standard and enterprise edition of SQL Server as deployed on-prem or within a virtual machine. Introduced with SQL Server 2017 is the ability to actually install and run SQL Server on top of a non-Windows operating system, specifically various different Linux distributions. Microsoft has direct support for Red Hat Enterprise Linux, SUSE Linux Enterprise, and Ubuntu Server. It is possible to actually get SQL Server to run on other platforms. These are, however, the officially supported distributions of Linux on which you can actually run the SQL Server. It is also possible to actually run SQL Server within the context of a Docker container. If you are therefore containerizing your workloads, this is an option for you. Originally, the Windows variant of SQL Server was actually fitted out for a Docker container. However, currently, Microsoft support for SQL Server within a Docker container is based upon the Linux build. The features and functionalities of the Linux build of the SQL Server product are fundamentally the same. The behaviors are the same, the APIs are the same, the communication is the same. And hence a lift and shift from running SQL Server on a Windows-based platform over to a Linux-based platform is more or less straightforward. There are, however, operating system fundamental differences that you have to actually deal with if you're actually migrating a SQL Server database workload from a Windows-based over to a Linux-based SQL Server instance. When you actually deploy an SQL Server, there are a number of different features that are available to be actually deployed. We have the database engine, which is the actual SQL Server itself. However, alongside of the database engine, you have a number of different subcomponents that are available, including integration services. Integration services, or SSIS, is a set of tooling to allow you to actually set up ETL, extract, transform, and load operations to move data from one location to another. There are cloud services that are actually designed to perform similar functionalities here, but with regard to the on-prem implementation of SQL Server, integration services is the subcomponent that actually handles that. We have analysis services. Within an analysis services database, you can actually create data cubes, which are multidimensional data structures, and you can actually define data mining models in order to actually extract meaning from your data. Within the analysis services database, you have options to actually directly store your data in a relational database or in a multidimensional data store in order to perform analysis on their data. We also have reporting services, and reporting services provides a mechanism by which a developer can actually build out RDL objects, publish them up to the reporting server, and the reporting server will retrieve and format the data coming out of a relational database or an analysis services database in order to allow users self-service access to reporting functions against the SQL Server. We also have master data services and data quality services. These are associated with ensuring that when multiple versions of the data exist, that you can actually manage that appropriately. Stream Insight similarly allows us to actually work with data in movement. SQL Server supports something called full text search. The full text search functionality allows me to go through and provide SQL Server with a more efficient mechanism to actually handle searches into unstructured data. SQL Server's internal indexing is very, very good at actually handling discrete values. However, when you take a look at unstructured data, such as a synopsis for a book and things like that, then building a full text search capability onto the SQL Server allows me to actually offload queries into that unstructured data in order to actually handle those much faster and more efficiently. SQL Server supports replication. The replication capabilities have a dependency on the SQL Server agent, and the Azure instance of SQL Server does not actually have an SQL Server agent. However, there are mechanisms by which you can actually incorporate an Azure instance of SQL Server into a replication implementation. Under replication, there are a number of different replication solutions depending on the nature of the data movement that you actually require. Unlike integration services, which is designed to actually bulk load data on a periodic basis, replication generally maintains multiple identical data sets. SQL Server also supports Power Pivot and Power View, as well as a feature called Polybase. Polybase allows you to submit queries to the SQL Server, which will then be restructured and redirected to a NoSQL implementation and or a Hadoop implementation, so that by querying into the SQL Server using things that look very similar to Transact SQL queries, we can actually incorporate result sets from both SQL Server and non-SQL sources. We also have the ability to actually interact with machine learning services, including R and Python. So there's a number of different services that are available depending on the requirements. When we take a look at general scalability of an SQL Server instance, specifically for an on-prem implementation and or a virtual machine implementation in Azure, a single physical server can actually support up to 50 instances of SQL Server. Within a cluster, we can actually have up to 50 instances depending on the storage mechanism that we're actually using. An individual instance of SQL Server can actually have up to 32,000 odd databases, and each database can theoretically achieve up to 524,000 terabytes in scale. There's no specific limitations on the size of an individual table within a database. It's based upon the amount of storage that you actually have available. When we take a look at hardware capabilities, the server has the ability to take advantage of the operating system's physical hardware to the maximum of the actual physical operating system. In this case here, with Windows Server Enterprise Edition, or the Data Center Edition, you have up to 64 sockets and cores, up to about 640 cores that you can actually address, plus appropriate memory, up to about 24 terabytes of memory. Is going to potentially be available. This is, of course, dependent on the version of the operating system that you're actually deploying the SQL Server upon. So there are some limitations on that, depending. When we take a look at the client tools to interact with SQL Server, a number of client tools are available. The primary administration tool for SQL Server is SSMS, the SQL Server Management Studio. Management Studio is available only currently for Windows-based platform. It is a Win32 architecture app. We do, however, have the SSDT, SQL Server Data Tools. And SQL Server Data Tools are actually able to be plugged into Visual Studio and hence are supported on Windows Visual Studio based systems. We have SQL CMD. SQL CMD is a pure command line interface. The pure command line interface can actually work with both on-prem and Azure SQL Server instances, and Microsoft has actually ported that over to both Linux and Mac OS. We have PowerShell for managing SQL Server. That is ported to both Linux and Mac. The Azure Data Studio is a newer tool for actually graphically managing SQL Server, and that is specifically cross-platform over to Mac and Linux. You also have Visual Studio Code, and then we have Azure Data Factory. Azure Data Factory is a cloud service and is fundamentally independent of the operating system that you're actually running. It's actually managed through a web-based interface. There's also an SQL Server Migration Assistant. There are actually plural of those depending on the platform they're actually moving from, and those are primarily associated with the Windows-based operating system. So a number of the primary administration tools for SQL Server have been actually ported over so that you can actually run them from not only Windows-based platforms, desktops, but also other desktops here. Some of the new features on various different versions of SQL Server, when we take a look at SQL Server 2014, that's when they introduced in-memory OLTP. We also have the buffer pool extension. Buffer pool extension is designed for servers that have limited RAM availability and have SSD or NVMe hard drives, where we can actually use SQL Server's page structure to actually handle temporary storage of data pages in the NVMe or SSD storage. SQL Server 2016, they introduce some encryption capabilities here for always encrypted communications between the client and the server. We have dynamic data masking, row-level security, and stretched database capabilities. Stretched database capabilities is the ability to actually have a single table in a database where a portion of the data resides in an Azure instance of SQL Server and a portion of the data resides in the local database server. And from the end user's perspective, it's actually transparent as to which portions of the data actually reside where. When we take a look at SQL Server 2017, they introduce automatic database tuning, Linux support, and SQL Server machine learning services, including Python and R. When we get to SQL Server 2019, they take the always encrypted capability of the client that was introduced back in SQL Server 2016 and build secure enclaves on top of that to allow you to actually run processing operations on the server side against data which is encrypted and therefore inaccessible to the actual server. We also have data discovery and classification. It's available here. In-memory OLTP, standard transaction processing, or what they refer to as row-level processing, uses transaction locks and a pessimistic locking model. In-memory OLTP, you relies on columnar structures and allows optimistic locking mechanisms in order to have significant increases in throughput for transaction processing with caveats associated with the types of data that you can actually do that with. So if your data complies with the requirements, you can actually get about 30 times improvement in transaction processing as compared to standard row-level transaction processing. But there are limitations on which workloads will actually work with that. So when we take a look at high availability, SQL Server actually provides a number of different high availability solutions. One is the always-on availability groups. The term always on here is a marketing term similar to Oracle's Unbreakable. And in this particular case, when we're talking about an availability group, what we're actually talking about is a solution for using data mirroring across multiple instances of SQL Server to provide a highly available database infrastructure with automated failover and other features. We then have failover clustering. Failover clustering is the standard mechanism for actually providing high availability to SQL Server and is available both in the enterprise and standard editions of SQL Server with some limitations. We also have database replication as a high availability solution where we can actually replicate data across versions and including from on-prem to Azure. We also have database mirroring. Database mirroring was introduced back in SQL Server 2005 and is the predecessor to availability groups. However, with database mirroring, we have a dependency on the client being aware of where the primary and where the mirror is. And in the standard edition, you don't have automated failover between the primary and the mirror server. So you had to go in and actually set up the data connector for a .NET Framework application to tell the application where the primary and where the mirror was, which is why in availability groups, they actually build that on top of a failover cluster. We have scale out capabilities with federated database designs. This is more a database design concept than a feature of SQL Server. However, there are a number of capabilities that are actually incorporated into the operating system in order to support that. We have some tools such as the Shard Map Manager, which is available in Azure in order to actually facilitate federated database structures. We have a very, very simplified solution for high availability here, which is log shipping, which provides us with a warm spare server that we can actually bring up quickly. And Microsoft has actually done some licensing accommodation here such that you don't have to actually pay for the licensing on the log shipping server until you actually flip it into production. You also have host clustering. In this particular case, host clustering refers to running SQL Server installed into a virtual machine on top of clustered Hyper-V hosts, VMware hosts, or some other virtualization platform, in which case the high availability is provided externally rather than internally. And when you actually take a look at host clustering is completely transparent to the SQL Server. Is it possible to use a standby instance for read-only database? Yes, it is actually. When you actually set up log shipping, there is a mechanism to actually have the database on the log ship server partially available online, and therefore you can perform read operations against it. There's actually two different solutions, one using snapshots and one actually bringing the database online in a read-only mode. So yes, you can absolutely, in a log shipping scenario, actually have the standby server used for read access. When we take a look at when we actually take a look at always-on availability groups is the primary solution for high availability with SQL Server right now. Within a availability group, you have exactly one primary read-write replica. So exactly one of the servers is actually performing read-write operations. Within the cluster configuration, you can then declare one or more synchronous replicas as read-only access, in which case, as queries are actually presented from the client through to the cluster control is going to be able to actually dynamically redirect read operations to one of the synchronous replicas and the write operations to the primary replica. That provides us with an efficient solution here. So you can have one primary and up to 8 secondaries. 4 of those secondaries can be synchronous in Server 2019. On Server 2017, you could only have 3 synchronous, and in 2016, you could only have 2 synchronous. So when you actually take a look at synchronous commit mode also incorporates automatic failover, allowing the primary, the read-write, to be actually re-identified dynamically via the cluster service in order to maintain high availability of access to the read-write copy of the data. All of this is actually based upon database mirroring technologies as the foundation. When you take a look at a failover cluster, within a Windows failover cluster, you can have up to 64 nodes available. Within the cluster, you can only have 50 instances of SQL Server running SMB storage. However, when you actually take a look at that, then you can actually do a clustered solution that actually provides you with sufficient resources to actually handle various different types of workloads. When you actually take a look at these solutions here, they have specific hardware requirements in order to be met, and they also provide a small amount of downtime during failover from one node in the cluster to another node in the cluster on the basis that failover actually occurs at the storage level primarily, whereas with database mirroring availability groups, in synchronous replicas, all of the data is committed at transaction processing time on multiple nodes. So there is a potential for small amounts of downtime with a failover cluster that does not normally present itself when you're actually dealing with an availability group. When we actually take a look at replication capabilities of SQL Server supports a number of different types of replication. Transactional replication, where we monitor transactional activity and we reprocess the transactional activity on other systems. Please note, all forms of replication introduce latency. The multiple replicas are not synchronous, they are asynchronous. We also have something called merge replication. Merge replication facilitates actually having multiple servers that are actually performing write operations to the data. There are specific physical changes that occur to the data tables when you actually set them up for merge replication that are required in order to ensure that we can actually track individual records and individual changes to records and etc. But you can then actually have multiple servers performing transactional operations independently. We have snapshot replication. We support what is referred to as peer-to-peer replication and bidirectional replication. And you also have something called updatable subscriptions, where a subscriber, which is receiving replication, can also be making changes to the data. When we take a look at SQL Server's security implementation, there are a number of security capabilities that are actually built into the SQL Server. When you take a look at the SQL Server client, it has the capability to actually handle TLS encryption. In order to do TLS encryption, you would, of course, have to provide TLS certificates to the actual server, register them, and then instruct the clients to actually flip over to encrypted communication. Please note, if you don't provide SQL Server with TLS certificates, it can't do encryption, and hence all your traffic is unencrypted, which is a problem. As an alternative to TLS, or in addition to TLS, you can actually do IPsec, but that is OS dependent. SQL Server supports transparent database encryption. Transparent database encryption is similar to something like BitLocker, which is encryption of the storage underlying the database, where once the database is actually mounted, the presence of that encryption is actually transparent to all applications on the server. We also support column level encryption and always encrypted. The difference between column level encryption and always encrypted, both of these are column based. However, always encrypted places the keys for encryption on the client. Therefore, the values being stored in the column are encrypted at the client, and the server will therefore not be able to decrypt and access the data, whereas in column-based encryption, the encryption keys actually reside on the server. You also have the ability to actually apply encryption to backups of the SQL Server, and there is some differentiation in terms of features by version. SQL Server also supports full auditing. It has a built-in auditing infrastructure so that you can actually monitor all activities inside the server and ensure that your security model is actually working properly. SQL Server also supports data classification and dynamic data masking. Dynamic data masking is a non-encryption based mechanism to actually hide data. So for example, let's say that I actually have email addresses stored inside the database. They're not encrypted inside the database. However, I want to obfuscate it from the client application. I can actually use dynamic data masking to actually do that. We also have row level security, where I can go in and define permissions at the record level rather than at the table and or column level, which has been available in SQL Server all the way back through the early versions. When we take a look at Azure, Microsoft has a broad range of offerings in terms of database solutions that actually exist in Azure. At the top of my list here, I actually have Azure SQL Server Database. In this case here, an Azure instance of SQL Server is a cloud solution, PaaS, platform as a service offering. You can also actually run SQL Server in a virtual machine in Azure. When you run SQL Server in a virtual machine in Azure, you spin up a virtual machine that is infrastructure as a service, IaaS. You then have 100% of the capabilities of the version of SQL Server that you actually deploy into the virtual machine. Hence, an Azure instance of SQL Server is fundamentally identical to an on-prem implementation of SQL Server, including the fact that you can actually incorporate Active Directory in Azure. There's two different models for that, and have your operating system joined to Active Directory in order to provide authentication and etc. You can also spin up a Linux instance in Azure. That's fully supported as well. There is one implementation here that is not on my table here. For some reason, I forgot it. And that is what's referred to as an SQL Server managed instance in Azure. An SQL Server managed instance in Azure provides you near feature parity with the on-premise version of SQL Server without the requirement for you to actually manage the underlying operating system as in an infrastructure as a service implementation. Beyond SQL Server, we also have Azure Synapse Analytics, which is ostensibly analysis services in Azure. We have HD Insight or a Hadoop solution. We have Cosmos DB, which is similar to MongoDB. We can actually spin up MySQL, Postgres, and MariaDB instances. And we also have Azure Data Lake and Analytics, which is a solution which actually builds on a series of capabilities, including the ability to go into a storage account and actually have table storage for unstructured table data inside of a storage account. So we have a broad range of different options available to us within the context of cloud services here. If I take a look at an Azure instance in Azure, I have two different licensing models. The two different licensing models that are actually available are identified as the DTU licensing model, right? And there is also the vCore licensing model. The DTU licensing model for virtual machine or SQL Server instances in Azure does not provide us with any visibility or information about the underlying structure. It's simply a platform as a service offering. Whereas when you actually take a look at vCore implementations, depending on which level you choose to pay for, are either very specifically multiple servers in a clustered implementation or in a availability group implementation. In this particular case, we have the regional gateway, which is going to be binding the IP address that you're actually connecting to. And if you actually take a general purpose service tier of vCore licensing, you end up with what is ostensibly a cluster. So you actually have highly available storage, you have a clustered instance of SQL Server, and you can then fail over from one node to another with the cluster. When we take a look at the premium and business critical tiers, you actually have what is ostensibly a failover cluster, sorry, an availability group. You have a Azure region where the termination of the IP address actually resides. You then have a primary replica, multiple secondary replicas. If we're doing the premium tier, you have two secondary replicas. And in the business critical tier, you can actually deploy an additional secondary replica into a different region in Azure. So this actually provides us with what is fundamentally the same basic mechanics of high availability that we have on-prem in Azure, where you don't have to actually manage any of those underlying structures. So that provides us with an understanding of what Microsoft is doing in the background, but I don't see any of that. Right? All I do is I actually connect in and I say, this is how much I want to give Microsoft, and they actually handle all the underlying infrastructure for me. So, all right. We're going to pause and see if there are any questions.
Thank you, Graeme. Yeah, we got a bunch. So just let me throw some out to you. Let me know if these have already been answered in your presentation, but I'll just go through the list that we have right now. First off, what is an SQL or SQL profiler?
What is the SQL profiler?
Yes.
I'm lost. I'm going to have to look that up. I'm going to have to check on that.
Okay, and unfortunately, I don't have any more information to provide. It was a very simple question, but I'll just jump on to the next one. What is in-memory OLTP?
Yeah, in-memory OLTP, I did actually mention this earlier, is a optimistic locking model for transaction processing when you're actually using column-based database tables. And its primary purpose is to alter the logic associated with how transaction processing actually occurs in order to reduce locking and data in order to assume that data contention won't exist and therefore allow transaction to be processed. And then when we're finished processing a transaction, we go back in and we actually look at the transaction to determine if it actually violated any of the data that was actually referenced. And if it didn't, we carry on. If it did, we just terminate the transaction and start over again. Sorry. Yeah, I just had the SQL Server Profiler. Yeah, I got lost for a second there. So the SQL Server Profiler is a tool that is actually included with the SQL Server Management Studio. And the SQL Server Profiler will allow me to actually run traces against the SQL Server. When you run a trace against the SQL Server, you're able to actually monitor real-time activity on the SQL Server. And with those traces, you're able to go through and look for anomalous activities, monitor real-time activities, and you can also feed the profiler traces into the Database and Tuning Advisor as a workload in order to actually identify potential modifications to the schema of the database or the structure of the indexes in the database in order to improve performance. So the profiler is a monitoring tool. Microsoft has announced that the profiler will be deprecated. However, I don't see them losing it anytime soon because although there is a replacement solution called Extended Events, which is more efficient than the profiler, there are still functionalities that you get out of the profiler that don't exist in extended events. So although Microsoft is actually pushing people forward towards extended events, I don't see them removing the profiler anytime soon. Yes. Sometimes words drop out the back of my head. I'm old.
Yeah, sounds great, Graeme. Let's see here, get the next one. Is it possible to use a standby instance as the reporting database in always-on setup?
And the answer is absolutely yes. In an always-on availability group, you have read-only servers, and the cluster service is able to actually send read-only activity to any read-only server. Generally, the automatic redirection is actually to a synchronous copy. However, if you have an asynchronous replica within your availability group, you can directly reference it because each instance in the availability group is actually independent, right? So if I simply connect to and interact with a asynchronous replica within the availability group, I can actually use that for reporting operations, bypassing the cluster's automatic distribution of read-write activity to the primary and read-only activity to the synchronous read-only replicas.
Great, thank you. Let's move on next. Can SQL servers be used as disaster recovery solutions?
Well, when you actually take a look at SQL Server, generally SQL Server is one of the most valuable assets that an organization actually has. When you take a look at disaster recovery solutions for SQL Server, amongst those disaster recovery solutions would be the ability to actually replicate data to a Azure instance or to another data center, the ability to actually have a stretch cluster. A stretch cluster in SQL Server would allow me to actually have 2 data centers and provided sufficient bandwidth between the 2 data centers. I could have nodes in the cluster in one data center, nodes in the cluster in another data center, and dynamically failover between data centers. So there are absolutely disaster recovery capabilities that are built into the high availability solutions on SQL Server automatically.
Great, thank you. Next question. Can SQL servers be linked to another server?
In this case, you can actually do replication between a Oracle source and an SQL server, where SQL server is doing the heavy lifting of moving the data. You can also have an Oracle destination. So if you can basically log into it and run a query against it, it is theoretically possible to interact with it. Beyond replication, within the SQL Server itself, we actually have a capability to actually set up something called a link server. What a link server does is I install the physical client software on the actual server itself for, let's say, Oracle, DB2, whatever, and then I create a link server object which actually references that client and the authentication requirements to get to that client. I can then actually run direct queries from my SQL server using 4-part naming across to a non-SQL. Actually, linked servers work with both SQL servers and non-SQL servers. So I can actually run queries on my SQL server, which will retrieve and process and integrate data from a remote data source. So absolutely, we have the ability to interact with remote data sources in SQL Server.
Perfect. Thank you for that. Let's see. Next question we have: how can you reduce the transaction logs of a database?
When you take a look at SQL Server, by default, SQL Server doesn't actually clean up the transaction logs. The one mechanism that is available to clean up the transaction logs is your transaction log backups. Therefore, if you do not have your database transaction log backups scheduled appropriately, your transaction logs will potentially grow very, very large. So what you want to do is take a look at the frequency with which transaction log backups are actually being taken. If your frequency is sufficient, then SQL Server will, backups of the transaction log won't stop transaction log growth. It will simply mean that the transaction log growth will be as limited as possible. So for example, if I actually submit a transactional query to the SQL Server that says, I want you to go through and actually delete 10 gigabytes from a 40 gigabyte table, the transaction log must be able to actually contain the 10 gigabytes of data that is being deleted. There is no choice, there is no option, and no matter how you actually schedule your transaction log backups, that transaction log is going to grow to accommodate the amount of data that is required by the transaction execution. So, quite frankly, don't worry about the size of the transaction logs. The transaction logs will grow to the size that they are required to be in order to handle the transactional activity that you're telling the SQL Server to do. The only option you have is twofold. One, scheduling your transaction log backups appropriately so that you can mitigate that as far as possible. And if you had some really anomalous activity, such as, you know, I did this 10 gigabyte delete from a 40 gigabyte table once and I'm never going to do it again, you can go in and manually relinquish space back to the operating system from the transaction logs. But by and large, just let the transaction logs grow to wherever they want to be and run your transaction log backups sufficiently frequently to limit that.
Great, thank you. Let's see, next question. Can you speak to the types of SQL subqueries?
Well, fundamentally, within a query, a subquery can actually, provided that it returns an appropriate data type, you can actually do almost anything within a subquery that you can actually do within the parent query. You will find that Microsoft is pushing forward with CTEs as the model for actually replacing subqueries. Where the benefit of the CTE is that it can be referenced multiple times without having to be repopulated. So some applications that were designed around the concept of subqueries end up literally having to actually regenerate the data multiple times during the process of the execution. Whereas with the CTE, provided you were within the operation boundaries, you can actually go back to the anchor query in the CTE multiple times.
Okay, thank you. Let's see, next one. Are there tools in SQL Server to migrate Oracle or MySQL databases to an SQL Server database?
Absolutely, yes. SQL Server includes a whole range of migration tools. There is a migration tool for Access, there's a migration tool for Oracle, a migration tool, etc. There's also a generic migration tool. Currently, Microsoft is actually pushing the use of the data migration tools that are actually available in Azure as the primary interface, giving you the most flexible options with regard to data source, data destination, transforms that you may have to do to your data as you're actually migrating it from place to place. And of course, Integration Services, SSIS, is designed specifically around moving data from one server to another. So if you're actually doing an on-prem implementation, migrating data over, SQL Server Integration Services through Visual Studio is where you want to take a look in order to actually define your ETL operations.
Okay, well, as a non-technical person, I'm not sure if this is related to SQL, but I'm going to throw it at you anyways. Let's see, this question is, which programming language is mostly preferred in machine learning, Python or R?
R's been around a little while, but Python is more broadly implemented in the NoSQL community outside of Microsoft. I would therefore go with Python, only because it's more commonly used outside of SQL Server. However, R certainly has its extended capabilities.
Great, appreciate that. Again, a little bit of a tangent, but I think you might be the perfect expert to answer this. Do you have any opinion? What's the difference between Microsoft Azure and AWS?
Do you have a month? Yeah. When we actually take a look at this, they're both cloud services. Their structures are very, very different. When you actually take a look at workloads, when you take a look at Microsoft Azure workloads are moving very, very rapidly towards open source technologies, where AWS is already there. So when you actually take a look at Microsoft's implementations on Azure, the new features, the new functions, the new capabilities, they're actually adopting very, very heavily open source technologies over there in order to put themselves in a direct competition space with AWS. Having said that, within Azure, you actually have very significant compatibilities with your on-premise infrastructure, which is a little more limited when we're actually dealing with AWS. So when I go in and take a look at Azure, the ability to, for example, synchronize on-premise Active Directory with an Azure Active Directory to actually fool my users into thinking that they're actually logging in as one account, things like that. So by and large, where you're actually dealing with workloads that are related to either Windows services, Exchange, SharePoint, et cetera, and or Active Directory authentication-based solutions, that is where Azure shines. And Microsoft is growing very, very rapidly in terms of their data center infrastructure worldwide. And their capacity is potentially going to actually be larger than other cloud service providers combined. So in terms of physical capability, Azure is actually making leaps and bounds forwards in terms of actual data center deployments, their government data centers, and et cetera. So yeah, it's basically like comparing right a Clydesdale to another horse that is not pejorative. They're both horses. Right?
Appreciate that, Graeme. So that covers all the questions. That's actually a great question and answer here. We got a lot of engagement. So I'm going to go ahead and move on. First off, thank you, Graeme. Again, a great presentation. I hope everyone enjoyed today's webinar. If you'd like to learn more about this topic, Global Knowledge offers several Microsoft SQL courses, including administering, implementing, and developing. In this time of social distancing, I would like to remind everyone that GK's entire Microsoft portfolio is offered in virtual and on-demand formats to enable you to continue to build your Microsoft skills safely. And as an attendee of today's webinar, we'd like to help you take the next step. Use these discount codes, webinar 25 in the US and CA webinar 20 and 25 in Canada to receive a 25% discount off your next Global Knowledge course. Finally, be sure to continue to visit Global Knowledge, the globalknowledge.com website to access additional free resources like technical articles, white papers, and other webinars. Thank you, stay safe, and have a great rest of your day.